Question 30. 5.22 into 10 to the power minus 4 of a gas containing hydrogen, oxygen and nitrogen exerted a pressure of 67.4 mm in a certain standard volume. The gas was passed over a hot platinum filament which combined hydrogen and oxygen into H2O, which was frozen out. When the gas was returned to the same volume, the pressure was 14.3 mm. Extra oxygen was added to increase the pressure to 44.3 mm. The combustion was repeated, after which the pressure read 32.9 mm. What was the mole fraction of hydrogen, oxygen and nitrogen in the gas sample? Partial pressure of hydrogen plus partial pressure of oxygen plus partial pressure of nitrogen is equal to 67.4 mm. Let this be equation 1. Now hydrogen and oxygen combine to form water and the balanced equation is 2H2 plus O2 forming 2H2O. As can be seen from the balanced equation, 2 moles of hydrogen combines with 1 mole of oxygen. Now at constant volume and temperature, pressure is directly proportional to number of moles. So we can write partial pressure of hydrogen as 2x and partial pressure of oxygen as x. After this reaction, the partial pressure of remaining hydrogen plus the partial pressure of nitrogen is equal to 14.3 mm. Let this be equation 2. Oxygen is used up in the reaction with hydrogen to form water. Now subtracting equation 2 from equation 1, we get partial pressure of hydrogen plus partial pressure of oxygen which combined to form water. Therefore, partial pressure of hydrogen plus partial pressure of oxygen is equal to 67.4 minus 14.3 and this is equal to 53.1 mm. As can be seen from the balanced equation, the partial pressure of hydrogen is 2x and partial pressure of oxygen is x. Therefore, we can write 2x plus x is equal to 53.1. Solving this, we get x is equal to 17.7 mm. Therefore, we can write partial pressure of oxygen equal to 17.7 mm and partial pressure of hydrogen is equal to 35.4 mm. Now partial pressure of remaining hydrogen plus partial pressure of nitrogen plus partial pressure of extra oxygen is equal to 44.3 mm. Let this be equation 3. Partial pressure of nitrogen and partial pressure of remaining oxygen is equal to 32.9 mm. Let this be equation 4. Now on adding extra oxygen, The remaining hydrogen combines with oxygen to form water. So subtracting equation 4 from equation 3, we get partial pressure of hydrogen plus partial pressure of oxygen that combines to form water. Therefore, partial pressure of hydrogen plus partial pressure of oxygen is equal to 44.3 minus 32.9, and this is equal to 11.4 millimeter. Therefore, we can write 2x plus x is equal to 11.4, where 2x is the partial pressure of hydrogen and x is the partial pressure of oxygen. Solving for x, we get x is equal to 3.8 millimeter. Therefore, partial pressure of oxygen in this reaction is 3.8 millimeter and partial pressure of hydrogen that took part in this reaction is 7.6 millimeter. Therefore, the partial pressure of hydrogen which was present initially and took part in both the reactions is equal to 35.4 plus 7.6, and this is equal to 43 millimeter. Partial pressure of oxygen which was present initially is equal to 17.7 millimeter. Partial pressure of nitrogen is equal to total pressure, that is 67.4 millimeter, minus partial pressure of hydrogen, that is 43 millimeter, plus partial pressure of oxygen, that is 17.7 millimeter, and this is equal to 6.7 millimeter. Therefore, mole fraction of hydrogen is equal to partial pressure of hydrogen, that is 43, divided by total pressure, that is 67.4, and this is equal to 0.638. Mole fraction of oxygen is equal to partial pressure of oxygen, that is 17.7, divided by total pressure, that is 67.4, and this is equal to 0.262. Mole fraction of nitrogen is equal to partial pressure of nitrogen, that is 6.7, divided by total pressure, that is 67.4, and this is equal to 0.1.